So the, the kind of next development with respect to ion channels is what is known as a gated ion channel. Ion channels are generally going to be closed, but open transiently to complete specific tasks. The opening and closing is known as gating. Okay. Now, gating occurs in response to a variety of stimuli. Mechanosensitivity, touch, sound, or other physical stimuli would be touch, sound, or other physical stimuli would be mechanosensitivity. Ligand-gated, binding of an extracellular ligand like a neurotransmitter. Signal-gated, binding of an intracellular signal molecule like calcium. Or voltage-gated, changes in membrane potential. So all of these are different kind of things that can cause a opening and closing to take place. An example of a ligand-gated channel would be the nicotinic acetylcholine receptor. This is found at a postsynaptic cleft, and what this does is it binds to acetylcholine. Here's our molecule of acetylcholine. I need to switch to my marker, my pen. Here's acetylcholine. Now, what that will do is acetylcholine will bind. I've got kind of an example down here. This molecule is closed, or this channel is closed, but then it binds two acetylcholine molecules and opens, enabling sodium ions in. Okay, so keep in mind we're talking about something outside versus in, so we're talking about sodium ions being right here, and whenever two acetylcholine molecules bind, well then, boom, it's going to flow through, and everything, those molecules are going to flow through. Now these are going to stay open until this enzyme known as acetylcholine esterase has taken that acetylcholine, produced acetate and choline. Now, many neurotoxins and chemical nerve agents affect either the binding of acetylcholine or act as acetylcholine esterase inhibitors. So think about what this means is you have a bunch of sodium ions. Now, those are outside of that synapse. If you basically keep this open, what's going to happen to all those sodium ions? They're going to flow in, they're going to flow in, they're going to flow in. Acetylcholine esterase is kind of a regulator of that, because what this does is it disrupts, or it takes that acetylcholine and breaks it down to acetate and choline. So that serves as a regulator, and if you have a neurotoxin or chemical nerve agent that either blocks acetylcholine esterase and prevents it from breaking it down into acetate and choline, well then you're not going to lose that acetylcholine, and therefore that channel's just going to remain open.